Hi, this is Andrea Hendricks, and I want to talk to you about graphing quadratic equations. We've looked at solving quadratic equations, and now we're going to bring in the concept of graphing those. And our focus in this section is only going to be equations of the form y is equal to a times x minus h squared plus k. And you'll see why by the end of this lesson why this is called the vertex form. Let me start one other thing. You don't have to worry about the concept of domain and range. That's going to be a topic you'll cover extensively in college algebra or math modeling, so don't worry about that concept for right now. Really, you're going to need to be able to find the vertex and graph the equation. Okay? So let's start with talking about the basic quadratic equation. And that is the equation y is equal to x squared. Now, if you didn't know the shape of the equation, you could actually plot points, right? By putting in like -2, -1, 0, 1, and 2. Well, the way I find y is I have to square the x value. So if we square a -2, we get 4. If we square a -1, we get 1. If we square 0, we get 0. Squaring 1 is 1, and squaring 2 is 4. And so whenever you graph it, notice that we'll have -2, 4. And again, graph paper would be great to use here. -1, 1, 0, 0, 1, 1, and 2, 4. And if we connect those points, we get the shape of what's called a parabola. Okay, and that's what every quadratic equation will have because it has some symmetry. Again, if my graph was straight, if I could fold it along the y-axis, the left side and the right side should be mirror images of each other, right? Because if I go out 2 units, I find a 4. If I go 2 units to the left, I find a y value of 4 on the graph. So that's where we get the symmetry. Now that point 0, 0, in this case, is called the vertex of the parabola. The vertex is either the highest or lowest point on the parabola. Okay, so we're going to study, if you remember that form I gave you, y is equal to a times x minus h squared plus k. What happens when we change those values of h and k and a? So let's look at that right now. So what I want to first look at is equations of the form y is equal to, let's just do x squared plus k. So all I'm doing now is looking at the number that is on the outside of the squared expression. So let's say we want to look at what happens if we graph y is equal to x squared minus 3, or maybe y is equal to x squared plus 4, and see what happens to the graph. Now we could certainly plug in numbers, but I'm going to use a calculator to demonstrate that. So if we go to the graphing calculator and press y equals, and we want to enter x squared minus 3. Okay, and now press graph. So what happened, it was the shape of the original parabola, really, that basic parabola, x squared, which goes through 0, 0, but every now was shifted down 3 units. You can also look at the table to see that. If we do second and graph, let me go back up some. what I want to compare the values to is, do you remember in the base y is equal to x squared, when we squared negative 2 we got 4, but notice here our output is 1, which is 3 less. When we square 1 we get 1, but minus 3 is negative 2. 0 squared is 0, minus 3 is negative 3. 1 squared 1 minus 3 is negative 2. 2 squared is 4, minus 3 is 1. So just decreasing the y values by 3. So what is the vertex of that? So look at the graph, it really was now down at 3, negative 3, and 1 was at negative 2, right? And then 2 was at 1. Okay. So it's still that same basic shape of the parabola, but it's just been shifted down 3 units. So the vertex of this is 0, negative 3. So we'll say that this shifts y is equal to x squared down 3 units. And you don't have to worry about this terminology of shifting right now. You'll cover that in the next course as well, but just to kind of get the idea. The vertex is a key thing, and being able to plot the graph. Y is equal to x squared plus 4. If we look at that graph, clear this out to look at squared plus 4 and graph. Now see what's happened. It's shifted the y is equal to x squared now up 4 units. And then if we look at the table, right, what we had before, if we squared negative to get 4, but now we're adding 4 to that to get 8. Squaring negative 1 is 1, add 4 to that to get 5. Square 0, 0, add 4 to get 4. Squaring 1 is 1, add 4 to get 5. Squaring 2 is 4, add 4 to get 8. So notice how around the vertex point, the y values actually repeat. And that's where, again, that symmetry, that mirror image comes into play. So the graph of this one is at 1, 2, 3, 0, 4. 1 was at 5, and so was negative 1. Negative 2 was at 8, as was 2. And so the graph of this looks like this, with the vertex of 0, 4. So it shifts y is equal to x squared up 4 units. Okay? So that k is really telling us the y value of the vertex. In fact, anything of this form, y is equal to x squared plus k, has a vertex of the form 0k. Okay. Now let's look at graphs that just have y is equal to x minus h squared. Since we're affecting the x before we squared in the previous problem, we didn't do anything to the x until after the squaring. Okay, so in other words, we're really just affecting the y values. So here we're affecting the x values. So the y value effect had to do up and down. If you can think about an x value effect, it's going to shift it left or right. And let's just see that. So if I look at what is the graph of y is equal to, let's say, x minus 2 squared. We'll go back to y equals and clear this out. This one, because you have to do it in parentheses. X minus 2, close parentheses, and then square. And now if we graph, and notice how this one shifts is equal to x squared from the vertex of 0, 0. It shifted it over 2 units. So if we look at the table, What happens now is that it takes in our x values to get the same results that started with, right? Because here we see 2 goes to 0, 3 goes to 1, and 4 goes to 4. So those y values we originally had are still happening, but the x value is larger now for that. So this one shifted everything over 2 units, so to 2, 0. Oops. And again, hopefully you'll have a better graph than me, but the vertex point is 2, 0. So actually it's whatever makes that inner expression 0 is the x value of the vertex, right? If I said x minus 2 equal to 0, I would get x is equal to 2. So that tells me how it's going to shift 2 to the right. So the vertex is 2, 0. And this shifts y is equal to x squared 2 units right. Now with the outer number of k, if it was positive on the outside, it went up. If it was negative, it went down. Well, here we have a negative sign inside, but it actually goes right. So that's because it has to be a larger value to make the same effect. So it's really the opposite of the sign. If the sign is a minus 2, the vertex is going to be a positive 2. Now what about y is equal to x plus 3 squared? If we look at that and change this to plus 3 and then graph it. Now we see that vertex has shifted to the left 3 units. And again, if we look at the table and go negative 3, do you see now it's negative 3, 0, and then the y value you've seen before for that initial basic graph that we started talking about. So this one has a vertex of negative 3, 0, and a negative 2 is at 1, negative 4 is at 1, negative 1 is at 4, and negative 5 is at 4. Now, how can you do this if you don't want to use the calculator, right? You can always plug in. Just to make sure that you get values around what's going to make that inner expression 0. So if that inner expression is 0, use at negative 3, then use like values around that, like negative 3, negative 4, negative 5, negative 2, negative 1, and then just plug in. Right? If I plug in negative 5 plus 3 is negative 2 squared is 4. Negative 4 plus 3 is negative 1 squared is 1, and so on. You know, in the final, you'll have your calculator. On the compass, you won't have a graphing calculator, and being able to identify graphs of parabolas is something that you have to be able to do on the compass. So the vertex is, but they're going to be in this form. The vertex is negative 3, 0. So this one shifts y is equal to x squared, 3 units left. Now, what if we combine the changes to look at y is equal to x minus h squared plus k, and we look at y is x minus 4 squared minus 5. So on the graph, do you have an idea of what you think? So we have x minus 4 squared minus 5. We have a combination of changes. We have this negative 5 on the outside of the square. So if you remember what we initially did, that has to do shifting down. In fact, here should shift it down by 5. The x minus minus 4 is going to shift it right by 4. So vertex is going right 4 units and down 5. Graph, we'll see that effect. So now vertex should be at 4, -5. And you can look at the table, and if we go to 4, -5, around the point we should see repeating values. And here's 4, -5. And symmetry on either that point is occurring. And so in your homework is to identify the vertex. So in this case is 4, -. We have y is equal to changing the sign on h, right? If that's a minus h, the vertex is just h. So you take the opposite sign of what's there. K, since it's positive there, it's the same value that we use. And then you'd have to be able to identify the graph. So 4, -5. And then again, if you wanted to make a table, right? 4, -5. We know it's there because 4 minus 4 is 0 squared is 0, minus 5 is -5. And then if we put values on either side of that, so if I put in 2, 2 minus 4 squared minus 5, 2 minus 4 is -2, squared is 4, and 4 minus 5 is -1. If I put in 3 minus 4 squared minus 5, 3 minus 4 is -1, squared is 1, minus 5 is -4. And then the values over here are going to repeat. I don't really have to do any work to find them, but you can. Okay? So we have 4, -5, and then, what, 2, -1, 3, -4, 5, -4, and 6, -1. Okay. Now, the last thing I want to talk about is that value of a. A has a lot of significance, but really the main thing you need to know in this case, if a is positive, the parabola is going to go up, right? Just like y is equal to x squared, the value of a, which is the coefficient of the square term, is 1, which is positive. If a is negative, the parabola is going to go down. Now, it has something also to do with how narrow or how wide the graph is, but that's going to be saved for the next course. But basically, to identify the vertex and the direction that the parabola goes, if I give you y is equal to -2 times x plus 3 squared plus 4, the vertex is, based on these numbers h and k, so -3, 4. The value of a here is -2, which means the parabola should go down. So we're looking for a vertex of -3, 4 with a graph going down. And we can look at that on the calculator to see that. So what is that? -2 times x plus 3 squared plus 4. If I graph, yeah, notice how I have the -3, 4 is my vertex, and then the parabola is going down. And again, you can look at the table to see that around 3, 4, right, the y values are symmetrical. Now, if on a final you were given just a table to say, graph this parabola for that central point around which the other y values are repeating, and know that central point is a vertex. Okay? So that's when this section, know how to find the vertex and select the graph. Selecting the graph from multiple choice you can do obviously by using your calculator, but I think it's also important to be able to plug in points. And if you remember how to plug in points around that value of x that makes the inner expression 0, then you'll always get the right relationship and see that symmetry that you need to. Okay, so if you have any questions on this, please don't hesitate to contact me. Thank you.